Okay, now let's have a look at how to calculate the upper and lower CDF values of chi-square distribution. So we know chi-square distribution. What is chi-square distribution? Chi-square distribution. Chi-square so chi-square distribution if we have z that is normally distributed with 0 and 1, if z1, z2 to zk are independent, normally distributed random variables with mean 0, variance 1, then if we have q is summation I from 1 to k zi square. This one will be chi-squarely distributed with k degree of freedom. So this k is the parameter that is a positive integer that specifies the degree of freedom. Okay? So this is chi-square distribution. Chi-square distribution is the sum of the squares of standard normal distribution, because this one mean 0, variance 1, this one is standard normal distribution. Since chi-square random variable is the sum of the squares, then it will be greater than 0. So most of the shape of chi-square distribution will be 0, and this is a chi-square random variable, k degree of freedom, and this will be the chi-square distribution, but 0 over here. Now, what is the upper CDF? This is the upper CDF, and this is the lower CDF. Okay? Upper CDF. This is lower CDF. Lower CDF is the probability up to a value, okay? Up to a location. And upper CDF is from a location to infinity. This is from 0 to a value. If we do the integration, this one is from a location to infinity. So this is the difference between upper CDF and lower CDF. Now let's have a look at the difference between chi-square random variable upper and lower. So if we know a location, for example, this chi-square 0 is our location. Lower CDF goes from 0, okay, up to chi-square 0. This yellow area is called lower. Lower, right? Upper CDF is this blue region. Okay? The blue region is the upper CDF. And also over here, it gives the lower CDF. This is the lower CDF here. lower CDF, that is a probability chi-square random variable less than a chi-0 square. And upper CDF is a probability chi-square greater than a location. Okay? So now let's find the CDF value of chi-square less than 1.649, v equals to 4. That means if we have a chi-square distribution, this is a chi-square distribution, chi-square, degree of freedom is 4. This is 0. And we're going to find from 1.649, and we want to find this area. This area is probability chi-square less than 1.649. This is degree of freedom is 4. So this is our location. So in order to use the Excel, we have a function called chi-square. So you see CHISQ dot distribution. And this one will have 3 parameters. Let's have a look at what are the 3 parameters. Oh. This one equals to, let me make sure it is bigger. This one equals to chi-square dot distribution, and we're going to have 3 parameters. The first one is the location. So the location is 1.649, and degree of freedom is 4, and this one is asked, whether it is cumulative distribution, because it's cumulative from 0 to 1.64. So we put true, it is cumulative. So this is 0.2, and this one will give us the lower CDF. So this function, chi-square dot distribution 1.649 4, 2, this one is 0.2. This 0.2 gave us this area. This area is 0.2, and 1.69 is this location, and it gave us the lower CDF value. Now, let's check the table for probability chi-square x, chi-square greater than 1.69, v equals to 4. This table, this table is actually from the book. You see, this is the v, degree of freedom equals to 4. But degree of freedom equals to 4, and 1.649, this is a location. You see this one? But this value is 0.8. Why it is 0.8? Yes? Why is 0.8? Yeah, this one is upper CDF. This is my location. Okay? This is my location. 4, location. And this is my probability, alpha. This is probability, this is alpha. This one is alpha. But this one gives us upper CDF. So that's why this one is 0.8. You see, chi-square greater than 1.649, v equals 4. This one is 0.8, but that one is 0.2 because 1 gave us a lower CDF. That one, Excel function, gave us a lower CDF. And this one gives us the upper CDF values. So in Excel, yes.
I'm just getting confused. What is the point 80? Is that the probability, or is that 80% of the data to the right of the 1.649? Or
Okay, very good point. So if we have 1.649 over here, this is my location. First probability cannot be greater than 1. Now we have a location, 1.649. This is my location. Lower CDF is 0.2. That means this area is 0.2. This area is also the probability that chi-square less than 1.649 when the degree of freedom equals 4. Okay? So this is the area. The blue area is the upper CDF. That means 0.2 plus 0.8, it should be 1. Right? If you know lower CDF is 0.2, the upper CDF has to be 0.8. So if once you know one value, and you will know the other one. So what I'm trying to say is, in Excel calculates lower CDF. Everything to the left. But in the book calculates the upper CDF. That's the point I'm trying to make. I'm trying to make it clear to you guys. Try to know the difference between lower CDF and upper CDF. Am I making sense? Any further questions? Yes? Okay, so that's the difference between lower CDF and upper CDF. Excel gives us the lower CDF values, but the book gives us the upper CDF values. But if we know the mechanisms, no matter what kind of CDF they give us, I know it is upper. I mean, they have to specify, right? For example, the Excel, they have to, in the book, yes?
Will we have to use the Excel formula for
When I introduce Excel skills, okay, when I try to talk how to use Excel to draw this plot, histogram, or normal probability plot, or how to use Excel to generate random number, right? Those are the practical skills that I hope you guys can learn, okay? And which is very, important skills when you get into get to a job and begin to do some data analysis. So, but for exams, exam has to be one computer won't be allowed, so you won't be able to use Excel. But in homeworks, you may need to use Excel, for example, to draw the normal probability plot. But I think Excel and how to use Excel to draw normal probability plot or do this kind of calculation, these are all very practical skills. I hope you guys can master. Okay, making sense? So that's the difference between lower and upper CDF. So if we want to know the exact specifications of the Excel function, this is the specific of Excel function, chi-square dot distribution function. This one returns the chi-square distribution, and it has 3 parameters. X is a location, degree of freedom, and a cumulative. So this is a syntax. It has the following arguments. X is a value at which you want to evaluate the distribution. That means we have to give this location. Now, if I specify this location, then you will be able to tell, and also you specify the degree of freedom, then you will be able to tell the computer or Excel to calculate the upper or lower CDF values for you. And this cumulative, this one is required because this is a logical value, true or false, determines the form of the function. If it is true, returns the CDF function. When this is a specification from Excel, okay? CDF function, but this CDF function didn't say it is lower CDF or upper CDF, but you can test it, okay? If you have a table, you can test whether it is lower CDF or upper CDF. But I have already told you this is lower CDF. Excel give us lower CDF, okay? And the book give us upper CDF. But it doesn't mean, okay, if I know lower CDF, I cannot calculate upper CDF. I mean, you can still do that. For example, if you just use equals to 1 minus this value, then you will be able to get this is a lower CDF, and the next one will be the upper CDF values. Okay? So this is a lower CDF and upper CDF. I mean, we got to use this function very flexibly to calculate the values we want. Okay, so far we finished how to use Excel to compute lower and upper CDF function of chi-square distribution. Now let's have a look at the t distribution. First, what is t distribution? We know that what is z? Z is normally distributed with 0 and 1, and x normally distributed with mu and sigma square. Now, x bar, if we know x, and what is the distribution of x bar? That is the central limit theorem. So x bar is normally distributed with mu sigma square over n. So now let's do normalization. The normalization is z equals to x minus mu over sigma, and equals to x bar minus mu over sigma over square root of n. So, but t will equals to x bar minus mu over s over square root of n. So what's the difference between t distribution and z distribution? Z is standard normal distribution, and this is t distribution. Now, for t distribution is the shape, this is the shape, and we have 0 over here too. And this will be t alpha over 2, and this will be alpha over 2. And this will be alpha over 2 and minus t alpha over 2. Okay. Now let's have a look at how to use Excel to compute the p-value of t distribution. So this is a handout I just gave you guys. How to use Excel to calculate p-values of the t distribution. So t distribution, in Excel we have a t dist function. This t dist function returns the percentage point, the probability for the t distribution, where a numeric value x is a calculated value of t for which the percentage points are to be computed. So t distribution, x, degree of freedom, and tails, has 3 parameters. So x is the location, and degree of freedom, because t distribution also has degree of freedom. So if you have n data points, the degree of freedom is n minus 1. Tails specify the number of distribution tails to return if tails equals to 1, you see here, that's different. It's not lower or upper. If tail equals to 1, t-distribution returns 1 tail distribution. If tail equals to 2, t-distribution returns 2 tail distribution. Okay? For example, for this example, you see here, if we have location 1.886, you see, 1.886, and degree of freedom equals to 2, and that is 1. You see here, this is my location. And this is upper CDF, right? Upper CDF, this is called tail. This is only one tail. Okay? This is only one tail. And this is 0.1. However, what is the difference between one tail and a two tail? So now let me draw the figure. Just now we have 1.886 and this is 1.886 and this is T degree of freedom let me write it over here. This is 1.886. This will be T distribution 1.886, 2 and 1. And this is approximately point 0.1, and this is 1 tail distribution. So if I specify 2 tail distribution, what's going to happen? If it is 2 tail distribution, that means if I have 1.886, 2 tail distribution, 2 tail distribution. 2 tails distribution will not only give you this area, but also give you the mirrored area over here, minus 1.886. So 2 tail distribution give you 2 tails, but it's symmetric tails. So if you use the function T distribution 1.886, 2 and 2, this will be doubled, like 0.2. Again, there are 3 parameters. This one is the location to calculate the upper CDF. Okay? This is the location. And the second one is degree of freedom. You can change the degree of freedom to 10, 11, or 12. And third one, specify, okay, I want this 2, or I only want this 1. So this is 1 tail distribution, 2 tail distribution. And this 2 tail distribution is also called p-value. So that's why we have p-value over there. If I give a location, tell me what is a p-value. The p-value means the summation of these 2 is my p-value. These 2 areas. Okay, now we just had a look at, but let's try. So if we have T distribution and this function, and we have X, it's 1.886, and we can have 2, and we can have 1. This should be 0.1, right? Let's see how. Is it 0.1? Yeah, it is 0.09. It's very close to 0.1. Okay. Now let's have a look at if we try 1.88622, this will be two-tailed distribution. It's about 0.2. Okay, this one doubles. Why doubles? Because we not only check one side, this one is only one side, one tail distribution. This one gives me the symmetric mirrored part, and then add these two together. That is two-tailed distribution. Okay, so at the beginning of this class, we finished the discussion using Excel to compute the upper or lower CDF or two-tailed CDF, two-tailed distribution of chi-square distribution and t distribution. And the same is applicable for the chi-square distribution. If you have lower CDF, upper CDF, you can also add these two together. That is the p-value for chi-square random variable.